Oh, Yash, can you hear me? And can you
Yes,
see the
yes,
screen?
yes, I can hear
Oh,
you.
okay.
Hello.
All right. So today we're going to do the chapter on probability models, conditional expectations, and adaptive forecasting, which is basically Bayes' theorem. Okay.
Right.
Uh, all right. So see, whenever we make an investment, right? So we are working on probabilities there. For
Right.
instance, what is the probability of the economy doing well? Or what is the probability that the sector does well? Or what is the probability that a stock does well or the company does well, right? So whenever we talk about investments, there's a certain degree of probability attached to it, right? Now,
Correct, sir.
stock or investment doing well is dependent on either the economy doing well or a sector doing well or the company doing well, right? So since we're talking about a chance that either of these fructify, we are talking everything in terms of probability. So every investment decision is basically a forecast, right? And probabilities will help us understand what is the chances of those investment decisions to be good in the future. Yeah. So
Yes, sir.
let's see how to use probabilities in the case of investment analysis or decision making. So the most basic way in which probabilities are used in is in calculation of expected values, right? So suppose if I make a series of investments, okay, in various stocks. So the first column is the stock number, and the second column is say the probability, right?
Right.
And the third column is what is the return expectation. And what is the probability of that happening is the second column. Third column is the return expectation. So suppose I say expected return of the stock one is 10%, and the chance of that happening is 25%. And then I say for stock two, it is 30%, probability of the return happening to be 15%. Now, if I make this portfolio and if I ask you what is the expected return on the portfolio, clearly the expected return on the portfolio will be nothing but the state outcomes, which are the returns, into the probabilities of those state outcomes, which are probability of returns. And
Right.
that's exactly what we are seeing here in this formula, that x's are the returns here, and p of x's are the probabilities. So whenever we make uh, any portfolio and we make investments in several stocks in that portfolio, we will have certain expectations of returns for each of the stocks, and we will also have an estimate of the probability. So then we can go ahead and estimate what could be the expected return on the portfolio, which is what we are seeing as this formula, and the manifestation of that formula in the discrete form is this, right? Any questions?
Right. No, no, sir.
Okay. Right. So here we're taking an example of a company which is analyzing Momentum Steel. Okay. So Momentum Steel is basically a company which it's a fictional company which we are taking into account. It's a domestic producer whose future is linked to economic conditions and potential government tariffs, which means that depending on good economic conditions, probably the stock of Momentum Steel will increase. And also, it also depends on certain government tariffs. Okay. Now, let's go ahead and understand a few other things. So, here is a small bit of an application. So, what is Momentum Steel's expected EPS? Yeah. So, can I say that we have assumed that momentum steel is based on the economic growth, right? So depending
Yes, sir.
on what kind of a scenario pans out for the economic growth, we want to find what is the expected EPS. Now we have a table here. In the first column is the column of expected scenarios. So we will take three scenarios here: strong growth, moderate growth, and recession. And we have probabilities of every outcome. Moderate growth is 50%, strong growth is 20%, and recession probability is 30%. EPS estimates have been forecasted for each of these scenarios. And the question is, what is the potential EPS for this stock or this company for the upcoming year? right? So similar to what we have seen on the previous slide, we can calculate the expected value of any variable using the same concept that it is summation of x into p of x, where x is the variable itself, the value of the variable, and p of x is the probability of the variable. So column 2 has probabilities and column 3 has x values, right? So P of X and X we have. So can I say I can calculate a new column of P of X into X, calculate
Yes,
the
sir.
probabilistic,
And you'll add all that, and that will
yeah,
be
and
the
we'll add
expected
all that, and that will be your expected EPS, correct? So that's a short example of, or a small example of how we can use the expectation concept, even for a fundamental variable like EPS, right? And this we can use anywhere. So if I tell you what is the expected ROE, return on equity, or expected, say, growth rate of the company, or what is the expected price of the company, etc. So this concept can be applied almost everywhere. But for that, it's very important to estimate two things. One is what is the probability across outcomes, and also what is the value of the variable in every outcome or scenario. Yes.
Yes,
So
sir.
this is how it looks. Okay, beyond average, if we want to calculate, so one is obviously what is the expected EPS. But suppose if I ask you, what is the volatility of this EPS? Okay, so volatility of the EPS is we are talking about risk of this EPS meeting certain expectations. And whenever we talk about volatility, we are talking about measurement of risk. So we have the good old variance formula, which is basically your probabilistic dispersion from the mean, right? So
Yes, sir.
we know that variance is equal to summation of xi minus x bar whole square divided by n. Now this formula holds true when I say that every outcome in my sample has equal probability because I'm multiplying xi minus x bar whole square, which is, can I say, dispersion from the mean. I'm square divided by n. So I'm multiplying everything by 1 by n. So in the good old variance formula, we are assuming probability to be equiprobable across outcomes and it should be 1 by n, right?
Correct.
Equiprobable. In this formula, on the other hand, what we are saying is every dispersion is having a different probability. And that probability depends on the value of the variable. So for instance, here for every EPS, we had different probabilities. So in this variance formula, we're going to attach different probabilities to the squared of the deviations and we sum it across and that's how we find the variance. In the previous example, suppose if we want to apply it to the previous example, uh, how can we do that? Can I say we will have another column, right? And that column will probably have x minus x bar whole square and we'll multiply it by probability, correct? And
Correct, sir.
sum of all of this column is going to give us the variance. And the square root of that is going to give us the standard deviation.
Standard deviation.
Yes. So expected EPS we have found out, right? So this x bar, can I say, is 1.97. And then x is this. So 2.5 minus 1.97 whole square into its probability 0.2. And we will do that for every row, right? And we can
Yeah.
create this column. And when we sum it up, we get the variance. The square root of the variance will give us standard deviation
Standard deviation.
of the expected EPS. So
Right.
in a lot of research papers, right, when you write a research paper or when you go across any brokerage report, uh, for various companies, right? So there you will always have uh, the range of expected EPS values across various scenarios. And then they also give you the standard deviation of that range. So how do we get that? We get that using all these calculations. Yeah, so that's a practical application of what we are seeing here. Another example of finding the variance would be to apply that to returns. So suppose we have this data set where in the first column is the return outcome. The second column is the probability of those returns. So for instance, what is the probability that momentum steel returns are 15% the next year? So that's 25%. Probability 10% is 50%. Probability of seeing return of zero is 25%. So given this data, so this is our data, right? Now, what is the expected return? Expected return, can I say, is just the multiplication of these two across, right? And
Right.
when we sum that up, we get 8.75%. So we have another column here which we can create, which is nothing but x into p of x. And that gives us expected return, which is 8.75%.
Got
And
it.
then we can calculate the deviation squared, which is nothing but x minus x bar. So your x is 15%, x bar is 8.75%. So that's your deviation. When you square that, you get this deviation square. When you multiply it with the probability of every scenario, you get p of x into x minus e of x whole square. And when you sum this, you will get variance. So we have variance equal to this value. And when you take the square root of that, we have standard deviation, which is 5.75%. So there's a 5.45% standard deviation. What is the meaning of this figure? 5.45%. Can you tell me?
So standard deviation, right?
Yeah. How do I read this figure?
So basically, the return of momentum steel, it can be 5.45% plus minus. Yes.
Okay. You're saying one standard deviation movement, correct?
Yes.
Okay. So one second. I'll just explain this. What do you mean by this? Okay. So
So
for that,
basically,
I'm
that's how
just,
much is going to be spread out from the mean, the
yeah,
return,
correct.
in short.
Correct. So in short, we are saying that, okay, when we create the distribution, the mean is at 8.75%, right?
Yes, sir.
And what is the one standard deviation up and down movement, right? Is this figure, right? So that's
Yes, sir.
5.45% and minus and plus 5.45%. So can I say the range of stock returns if one standard deviation movement on both sides? So what is the range of that? Can I say it's 8.75% plus 5.45 and
Yeah.
8.75 minus 5.45?
Yes, sir.
Makes sense, right? So whatever
Yes.
that is, I think that is 14.2 and it is 3.3%,
Yes.
right? If I assume that there could be a wider dispersion, and if suppose I wanted between minus two standard deviations and plus two standard deviation, then these calculations will be plus minus two sigma, and
Yeah.
your
So the
return profile will be
10.9.
correct. So you'll have to just add 5.45 and subtract an additional 5.45 from the previous answer, right?
Yes, sir.
So basically, this will be addition of 5.45, so 19.75, 65, sorry. And the negative return will be what? 3.3 minus 5.45. So that will minus 2.25, correct?
Yes.
So on a two standard deviation negative movement, we say that there could be a possibility that there could be a negative return on this stock. Yeah. So that's how we use these figures of expectation and standard deviations. Cool, right?
Yes, sir. Got it.
Yeah. Okay. Now comes the important part of creating probability trees. So what are these probability trees? These trees are events happening one after the other. So whenever a single event happens, okay, we can build a very easy short tree. Okay. Just one second. Explain that. Yeah. So what is a probability tree? Okay. Suppose we have a single event. In a single event, whatever is the event here, there could be several outcomes for the event. Okay. And each of the outcomes, so suppose this is outcome one, outcome two, outcome three, will have certain probabilities attached to it. So this is how a simple probability tree looks like for a single event, where depending on the outcome of the event, I could have probabilities of those outcomes. And those outcomes are given as outcome one, outcome two, outcome three, and the probabilities are put on the branch nodes. So can I say there's a branching of the event, right? And the
Yes,
branching is because there are three possibilities of outcomes. So this is a simplistic probability tree which only involves one event. A more complicated or a complex tree is where events are based on each other. So suppose you have event one that leads to event two, that could lead to event three, etc., etc. So when there's a series of events which are linked to each other, so that's where you will have certain complex trees. For instance, I could have event one, it could lead to, say, three different outcomes. And on this outcome, I could have, say, event two, and that could lead to further outcomes, right? Event 3 year, event 4 year, and so on and so forth, right? Can I say event two is conditional on event one exhibiting a certain value, right? For instance,
right.
event one could be stock returns or maybe economy. So can I say when economy goes up, event two happens? And what is event two? Event two could be, say, sector going up, sector flat, or sector going down. Okay. So event one could be economy. Event two could, event here at this level could be, say, sector. Correct. So event one is economy. It can have three outcomes: going up, flat, or going down. So the second level here is if the economy is 2 o'clock. When the economy is going up, yeah, I could have several scenarios of the sector. It could go up, it could be flat, or it could be going down, right? So can I say event two is dependent on event one? And that's where we have the introduction of conditional probability, where I say event two conditional upon event one. Yeah. So these are probability trees at the end. Can I say these are in the first case when we have a simplistic tree, the end nodes are where we can directly find the probability, right? So probability of seeing the first outcome O1, can I say is just P1 because there's only one branch which leads to outcome one. However, if I were to calculate the probability of this node, can I say probability of this node is the branch multiplication of the branch probabilities leading to that node. For instance,
Yeah,
node
right,
A
sir.
probability is this branch into this branch.
Correct.
For this node, it will be probability
This
of this
branch into
branch
that
into
other
probability
one.
of this branch. Correct?
Yes, sir.
So those are called as nodal probabilities. Yeah, so I'm just explaining the various terminologies in a tree diagram, in a probability tree. So there
Okay, sir.
is the branch probability, which is the probability on the branch. And then there is something called as nodal probability, which is the end outcome, probability of the end outcome. Make sense? Yeah.
Yes, sir.
So with this structure, we can probably look at an example. So this is an example of from the same momentum steel, right? So let's map the potential EPS for this company based on two sequential events. One is the state of the economy, and the other is what is the relative performance of the company within that economy. Okay. So level one is where we have two outcomes of good economy and bad economy. Yeah. And the second level is where we have the company's relative performance within that economy. So, given the, okay, so can I say it starts with 60% probability of good economy and 40% of poor economy, correct? If the
Yes, sir.
economy is good, then what is the probability of getting good company results? So that's 70%. And the probability of bad results given a good economy is 30%, right? So now if I ask you, what is the probability of this node, which means where the economy is good and where the company posts good results. So can I say that probability or joint probability is nothing but the branch
Point 0.6
probabilities
into point
multiplication?
0.7.
Correct. So that's 0.42. Makes sense? And
Yes,
hence
sir.
on the tree, for every end node, we can have a joint probability. That is nothing but the multiplication of branch probabilities.
Correct, sir.
Okay. So that's how it looks. There's a concept of conditional expectation. And here, can I say the good company results, can I say is conditional upon good economy?
Yes, sir.
Makes sense. So how do I write this? What is this probability? Can I say this probability is nothing but a probability of good company results given that it's a good economy outcome. Correct?
Yes, sir.
That's how we get this probability of zero point 0.7. That's how we can write this zero point 0.7, right? So what is this zero point 0.7? 0.7 is nothing but good company results given that it's good economy. So can I say it's contingent upon a previous outcome of an event, right? And
Yes, sir.
that is what is conditional probability. Exactly. So it's conditional on a prior event. Make sense?
Yes, sir. Understood.
And what is this zero point 0.3? How do I read this figure? Can I say that is probability of poor company results?
Probability of poor company results
Hmm.
based on the fact that there was a good economy.
Correct. So can I say all these are conditional probabilities?
Yes, sir. We can
All
say that.
these second level onwards, whatever branch probabilities you see are all conditional.
Yeah.
Okay, fantastic. And that is what I've explained you as conditional probability. Now coming to the most important stuff here, which is talking about Bayes formula. Okay. Uh, Bayes formula, I will explain using an example to you. Yeah. For that, let's come back to the same example. Okay. I'm going to just copy this example here. I'm going to explain the Bayes. Okay. Same example. Can I say this we were reading as what? Probability of good results given that we had a good economy outcome, right? And that is equal to what? Zero point 0.7. Now, what is the probability of good company results if I ask you? Probability of good company results.
Good company results.
Can I say there are two outcomes which lead to that?
Yes,
Or
sir.
two
No.
branches? Can I say this is the
Yes.
first branch and then this is the second branch? Which means even in good economy, there's a higher chance, of course, of having good company results. But even in a poor economy, a company can post good results, right?
Yes, sir.
So can I say this can happen in two ways? Can I write this as total branch one and this is the second total branch two? On branch one, what is the probability? Can I say zero point 0.6 into zero point 0.7?
Yes, sir.
And can I write plus zero point 0.4 into zero point 0.2?
Yeah.
And can I say that will be the probability of seeing good results?
Okay. So that
And
will be
what is this zero
50%
point
then.
0.6? Yeah, what is this zero point 0.6? Can I write this as zero point 0.6 is
The
probability of
good
economy
economy.
up? Yeah,
Yeah.
economy up. And what is this zero point 0.4? This is probability of economy down.
Poor Yeah.
And what is this zero point 0.7? Can I say this is of results up given that economy is
There's
up,
a good economy.
right? And what is this zero point 0.2? Zero point
Uh,
0.2 is result up given the fact that economy
Economy
down.
down.
Correct. Right. So this is how it looks like, right? So probability of good results, which is nothing but probability of result up, can I say, is equal to two probabilities, multiplication of two probabilities. That's because company having good results, there are two paths to it. Path one, path two, and these are the probabilities on every path. Multiplication of all branch probabilities will give probability of a path. Correct? And what is the probability of bad results? Can you tell me?
So got the bring down, right? So
Yeah.
it will be zero point 0.6 into 0.3
Okay. It will be zero point 0.6 into zero point 0.3. Very good.
plus zero point
Plus
0.4 into 0.8.
zero point 0.8. Correct. Okay. Fantastic. So that's your
Yeah.
probability of the results going down. Now, what Bayes' probability says that is given now, Bayes' theorem says that given that you know the company is going to post good results, what is the probability that, okay, or what is the probability that the economy is good given that the company posts good results? Opposite.
Okay, so we're going reverse.
Yeah. So we are saying now we know what we know that the company has posted good results. What is the chance that we are on path one instead of path two?
Okay.
So can I say Bayes' theorem is asking us what is the probability of path one versus probability of path one and two? That is exactly what Bayes is asking us, which means given that company has good results, so we know that okay, company has good results. Now the question of Bayes is, does it come from path one or does it come from path two? That is what Bayes is trying to answer. What is the probability that the path one has happened, or what is the probability that the path two has happened? Correct. So
Correct.
Bayes is flipping the conditional probability in the second case. In the second layer, can I say we have conditional probability of given the fact that we see a good economy now, but now we are seeing good results, and tell us what was the probability of seeing good economy, which means what is the probability of path one that it came from path one. Okay. So how do we solve this?
So then we'll take the form, use the formula, right?
Just take the probability of path one and divide it by the sum of all the paths. Make sense? Which
Yeah.
means, how did we get to path one? Good results. Can I say that was path one, this one?
Yeah.
So
So
what is the
zero point 0.6 into
probability of
point.
that? Zero point 0.6 into zero point 0.7. And how many paths led to good results? Two paths, one and two,
Yeah.
right? So can I say denominator will be zero point 0.6 into zero point 0.7 plus zero point 0.4 into zero point 0.2. So your denominator is essentially what? The
The
sum
sum
of
of all
the
the probabilities
paths.
that are leading to that outcome.
Correct. That are leading to the good company results outcome, right?
Yeah.
And the numerator is what? Only the path which leads to the good company results using good economy.
Good
Because that's
economy.
what we want to calculate,
Yeah, we
probability
want to
of
calculate
good
the probability
economy.
of good economy.
Yes. And that lies on the first path. If in this Bayes theorem question, if I were to ask you, uh, one second. This is what is happening. My laptop is just hanging today. Uh, if I were to ask you what is the probability of eco down, given that you see good results, what will be that answer?
Economic down and good results, right? So
Hmm.
that will basically part economy down. Wait now. So you
Yeah.
will take the paths which are leading to the poor result. So no, the results are good, right?
Results are good. So what is again? I'm reiterating. Sorry, I can't write it here. It's just stuck. The question is, what is the, let me just take a quick snapshot of this. Okay, I'll just maybe open Excel. Yeah, just 1 second. Huh? Yeah, yeah. So now my question is, we've looked at this, right, using Bayes theorem. My question is, what is the probability that it that we see good results, given that we see good results, that is what we see,
Yeah.
and we need to find the probability that it came from bad economic outcome or poor
So it
economy.
will be zero point 0.4 into 0.2 upon
Yeah,
the 0.6 into 0.7 plus 0.4. Yeah, right. Got
into divided by what?
it. 0.6 into zero point 0.7 plus
Okay, zero point 0.6 into zero point 0.7 plus
0.4 into 0.2, right?
zero point 0.4 into zero point 0.2. Exactly.
Right.
So can I say here the numerator was related to path 1? Here the
Yeah.
numerator is related to path 2,
Okay.
because this event is related to path 2 and this event was related to path 1. Correct?
Understood, sir. Yes.
Fantastic. So now, even if we have a more complicated tree, Bayes theorem, I think you should be able to answer any question on Bayes theorem given this logic. So what does Bayes theorem ask us? Bayes theorem goes reverse and asks us updated priori probabilities, where it's saying that we know the end outcome, and what is the probability that, given that we know the end outcome, what is the probability that it came from, say, the state outcome being good economy or the state outcome being poor economy? Make sense?
Yes. Good.
Yeah. So this is A and this is B. Make sense? Okay. Good. Okay. This is how. You have any questions on whatever we have done so far?
No, so far I understood it, sir.
Is base clear to you?
Yeah. Yeah. Totally it's clear.
So let me just shut it and restart. So I think I've lost that previous file. Looks like. Okay. Okay, no worries. Let's just continue. So we are through with this. Yeah. Okay, this is the same example which we have solved. Okay. Same example. Yeah, similar looking example. So you can just go through this, Yash, later on.
Yeah.
I will give you some 3, 4 questions to solve on
Okay.
Bayes theorem and on conditional probability entry, and you can just solve them. Let me know how it goes.
Sure, sir.
Okay. Anything else you want to ask?
No, no, sir. So
Yeah.
I'll be coming back to India on Saturday night.
On
I've
Saturday
told
night.
Vaidhi. Yeah, I've
Okay.
told
Okay.
Vaidhi
So
to leave the
next
US.
week, I think you should come to office. We can have longer sessions.
Yes, sir. Let me know what time and stuff, and I'll come and what
हाँ
dates.
ठीक है Sure, sure. ठीक है? So I'll
Yes.
see you soon then. Yes.
Yeah, sure, sir.
Okay. Bye bye.
Thank you, sir.
Thank you.